From the morning caffeine fix to cooking dinner, our energy needs fuel our daily lives. And it's right there, in our homes, where researchers at the Biocomplexity Institute of Virginia Tech found we can make the most difference when it comes to alleviating the stress on our energy grid in the United States.
Primarily, the energy systems were viewed from the standpoint of a producer and the grid that transmits the power to the end user. The role of consumers, or what's called in economics the demand side, was rather weak.
Work coming out of the Biocomplexity Institute adds expertise to ongoing research of smart grid technology in 3 components. First, the Institute has access to high-performance computing, which allows researchers to delve further into the human elements of the smart grid.
Humans are not viewed as passive customers, households are not viewed as passive customers, but they are viewed both as producers of energy and consumers of energy.
Second, the Institute has the expertise to evaluate the large data sets produced from a smart grid.
As a smart grid becomes a reality, the devices that are placed on these grids produce large amounts of data, from smart meters to power electronic devices to phasor measurement units, to devices that allow you to control the household consumption of electricity, things that various companies are making, like Nest.
And finally, he says,
the Biocomplexity Institute brings to the table is an ability to build software systems and architectures that allow decision support tools to be built on top of it, apps to be built on top of it, database systems to be built on top of it, so that it can support not just large-scale companies like AEP or Dominion, but also individual customers who are interested in controlling the use of power to make their lives more efficient in terms of energy usage.
As for customers, that efficient energy usage can translate into lower bills. When individuals choose to add alternative and renewable sources of energy, it could also help to make the overall grid less susceptible to failures. And that helps reduce our carbon footprint. As Dr. Murate explains, our current energy infrastructure is more than 100 years old. As we continue to use more and more electronic devices in our everyday lives, demand on that aging infrastructure will continue to increase. A smart energy grid, he adds, has proven successful in parts of the world where it's already in use.
What we have built out here is a way to understand the usage patterns of individuals and households at a residential scale, at a very detailed residential scale in the state of Virginia, but we want to extend this model to the entire United States. Once such a model is built, it can be used to carry out multiple policy studies.
And educated consumers can go to bed at night knowing they were part of the solution.